Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is create binary tree from descriptions. Okay, and the problem statement goes like this. So you are given a 2D integer array descriptions where each node is represented by a description, and description about a node includes its parent, its value. Okay, this node can be a child of some parent, or and then the third information about the node which will be given in the description is whether this node is the right child or the left child of its parent. Okay, so if left is 1 then it's left child, and if is left is 0 then it's right child of its parent. Okay, and you have to construct the binary tree and return its root. Okay. So let's try to solve this problem, and before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, the description length will be of order 10 raised to power 4, and each entry in this array will be of size 3. The first entry in the description of each node represents its parent, then its value, and then its parent's value, its value, the node's value, and whether this node is left or right child of its parent. Okay, so these three will be there, and parent and child values will be of 10 raised to power 5 order. Okay? And either the node will be the left child or the right child, and depending upon that, the values, corresponding values, will be 0 or 1 or 0. Okay, and the binary tree is described by the descriptions is valid. Okay, so it is a valid binary tree. You need not to have a separate checks for that. Okay, now let's try to understand how we can solve this. So let's copy one of these. Let's copy this one. So let's copy the input only. Okay, so this is the input, and just for the sake of clarity, this is parent, this is child, and this one is whether it's left or right. Okay, so this is the node's value actually. Okay, so what we will be doing here is, so in a way it is very easy to construct a tree from this. What we can do, we can traverse this array from left to right direction. Okay, and visiting these nodes descriptions one by one. Okay, now let's say you are at the very first description, then you will be knowing that for this parent you have to make this node as left child. Okay, so you must be having address of this parent. Okay, so in order to store the address of the nodes, what we will be doing here is we will be using a map. So map, one side will be the nodes values, and then other side it will be tree nodes reference. Okay, or address. So nodes value is 20. Let's say address is something like x. Okay, so this way you will keep storing. Okay, so it will be the nothing but object of tree node. Okay, so once you are having a hold of your node 20, then you will be making it the left child of 20. So let's bring down the figure here so that we can easily see how we are forming the node uh, tree. Okay, so this is the tree. Now you have formed this link 20 and its left child. Okay, till now your tree is complete. Then you will get hold of 20 again with the help of this map. Okay, now once with the help of this map you get hold of this 20, you will see that 17 is the right child, so you will make it the right child of 20. So this much is done. Then comes 50, get hold of 50, make 20 its left child. Okay, so make this connection. So in a way you will keep proceeding like this, making 80 as the right child of 50. Then again 80's left child should be 90. This link is live again, live now. Okay. So in a way you just constructed the whole tree. Now the remaining problem is that you have to find the root. Okay. To find the root, what you can do is you can have a map kind of thing, out degree, or you can say in degree. Okay, instead of out degree, let's take in degree. In degree is the number of edges, or the edges which are incident on the current node. Okay, coming to the current node. So initially all the nodes will be having in degrees equal to 0. When some edge is coming towards a node, you will decrease is in degree. So 80 is in degree will be, let's change the color here, -1. Its in degree will be -1. Its in degree will be again -1. Similarly, this one will also have -1. This one will also have -1. This indicates that they are at least have one parent. But for 50 it will remain 0, so that we can easily find out 50 with the help of this in degree concept. And this in degree can be nothing but a map only. So it will be node value and its in degree. Initially in degrees of all these will be set to 0, as when you are finding out that a current node is having a parent, so 15's in degree will be reduced to -1. Okay, similarly 17's -1, 20 -1, 18 -1, and 19 also -1. So what is left out? Only 50 is left out. Okay, so and for all the parents, if the parents are not part of this node value and versus degree map, then you will insert the parent also. So somewhere around traversing this array, you will insert 50 with value in degree value 0. Okay, so this way you will insert the 50 value also. So let's have a quick look at the implementation. So this is the implementation, and let's take it to the board. So this much is the implementation part. We can zoom it out, zoom in a little bit. So this is implement. Okay, so let's discuss what's happening here. First of all, as we talked about, we will be needing two maps. One is the in degree map and the value node map. Okay, so value versus node. So as in the in degree, it will be node's value and its in degree. Okay, so both will be of integer data type. Okay, and for the value node map, it will be node's value, which will be in integer, and tree node object, which will be of type tree node. Okay, so that's why these two. Now we will be traversing each description one by one from left to right direction. or you can traverse in reverse direction also, it really does not matter. But here we have taken left to right. Okay, so the first entry will be the parent, second entry will be the child or the current node, and then there will be a boolean variable telling you whether the current child is the left child, or the current node is the left child of its parent or not. Okay, and for each of the parent we will be adding it inside our value node map if it is not already there. Okay, for each parent, and if it's already there then we need not to worry about it. And then in the degree of the current node will be decremented by 1. By default it will be set to 0. Okay, and then value node map will be added the values of the parent and the current node, which is the child of this parent. Okay, and once you are having all those values, then you will make the connections. So you are here making the link between parent and child. Okay, so if it is the left child, then your parent's left link will be updated, and if it is the right child, then your parent's right link will be updated. Okay, depending upon that. And we are getting all these values from the node map, so we are pretty much sure that we are not creating any node. No, each time we are getting a new sibling for it, or, or new offspring for it. Okay, so and then you will be simply traversing your degrees array. So once you get hold of the 0 degree node, then you will return it as a parent. Okay, and this null statement, although it will never reach, because you will always have some parent. Okay, as the number of nodes, uh, you know uh, there will be at least one node, so you need not to worry about that. Basically there will be at least two nodes, because the parent node will not be present in the description array. Okay, so we are fine with that. So this null will never be returned. So overall time complexity wise, this approach is order of n, where n is the number of nodes. Okay, and space complexity wise, it's order of n also, because of use of these maps, and these will be storing at least n nodes. So n nodes only, because every node will be there in these both of these maps. So order of n space complexity, and these are the complex. So if you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSS skills. Till then, keep practicing more and more problems, and I will see you in the next video. Thank you for watching.